Hi there. Right. Let me start. So I'm going to talk really about artificial intelligence and why is that a big deal? Well, it's going to be a large part of our lives in 15 years. It may already be quite a large part of our lives. I used a AI system to book my flight here, which was a disaster. So at the moment, AI systems are not great, but they're improving very rapidly. So one of the things that I think we find with the sort of AI revolution at the moment is that really people and machines think very differently. And we are kind of creative and we do all this sort of wacky stuff and go to conferences and so on, and machines just sit there and compute. And some of you may know I founded the Roger Penrose Institute, and he's big into this, what's the difference between human and artificial intelligence? And he did this puzzle for which we got 5,000 responses, which is, and how many people play chess here? Right, so win, lose, or draw? Those people who play chess. So machines think that black's ahead because they've got lots of pieces. In fact, it'll be a draw because there's no way of actually getting these bishops here have no power over the king, and there's even a way of tricking the black into losing. So we think very differently, but of course it could be just a matter of time, right? So eventually IBM Watson and all of the various AIs get good enough to win. And if you do the analysis, that might happen somewhere around 2037 is when computers have the same number of gates as our brain. And there's some people who believe that brains are quantum devices rather than classical devices. But in that case, we just have to wait until 2080 before computers get as good as us. So there's this kind of worry that one day, Wozniak there says that one day we will be the pets of computers, just as our dogs today are our pets. But at the moment, AI is in a very sort of strange area. So if you look at image recognition, computers are now better than us. So a computer will characterize cheetahs and cats at greater than 97%. And in fact, we're not as good at doing that. So it's very hard to test those machines because what's the test? We can't do the classification. If you look inside, I know Travis was trying to explain yesterday how these AI deep learning networks work. One way you can sort of see how they do it is to run an AI network and try and persuade it to perfectly recognize an image. So this is a perfectly recognizable dog to an AI. And you can see that it sort of looks at features, and certain features are dominant for it. So the eye, and it eyes in certain places. So it's just looking arbitrarily for features. So it's quite interesting that you can therefore trick today's AIs completely. AIs don't have any sort of thing like common sense. So all of these pictures are perfectly recognized by an AI as the word. So for example, what's a really one? There's a bagel there, right? That's a perfect bagel according to an AI. But that green thing with a line through it, that's a sea snake, perfectly recognized. That's a digital clock, perfectly recognized as a digital clock, and yet it's not. So they don't have any common sense. They can't look at something and go, oh, that's just, you know, an abstract picture. So we founded this company called Sen AI, or Sen Inc. And the idea of Sen is to pair humans and computers so that we actually can use human intelligence and artificial intelligence at the same time. And so we have like 3 principles that we're working with. One is that at the moment, the way that we're doing AI is not really fair. So we take people's knowledge and we put it into the AI of a big corporation, and then those people don't get any benefit their knowledge in the future. The second one is that today's AIs are just not very good, right? They answer questions very badly. It caused me not to get the flight I was hoping to get. And also at the moment, we're harvesting our data and putting it into central repositories, and these repositories then know lots of information about us. And this is really the wrong way to do it. We should keep control of our data. So let's look at these sort of features. So at the moment, we crowdsource quite a lot of information. So about 30% of information on Google searches is crowdsourced. It comes from answers that have been put into Wikipedia and Quora and so on. So there's a lot of data out there that we provide. And there's a lot of data, a lot of answers to questions in the world. There's something like 2 trillion answers out there that we've already written down in books and so on. The problem is that those answers that are out there that we want to get are impossible to get because they're written in English, which is extremely ambiguous, and the way that we write our information rambles and is advertorial and so on. So I did an example. This was, what mobile operator should I get? So this is a Google search. So the first one is an advert for Fairphone, which might be very good, but it's not what I was expecting. I was expecting sort of Verizon or something like that. The second one was junk. Rook and Dock are good starters, die defense. The third one offered me a mobile service in Chile. I was doing the search for America. And the fourth one was a list of all the mobile operators in the world from Wikipedia. Right? So the problem at the moment is that if we ask questions from AI or if we ask questions from the internet, we don't get good answers. And so what we're proposing and what we're trying to answer is this movement from the information economy today to an intelligence economy. So in an information economy, it doesn't matter that you ask a question and you get gibberish back because you are the tool, you are the machine, right? You are the intelligence. You just look at the first page, go, this is all junk. You go to the second page, eventually you'll find Verizon, eventually you'll find something and you'll work it out. But in an intelligence economy, you expect to talk to an artificial intelligence and say, I need a mobile operator. I need, an open source communications platform. I need something. And you expect to get the answer back from it that's essentially right first time. And so that's a big change in the economy. So we do a few things. So we do a few things to solve that problem. So we have provided a Bitcoin-based or a token-based economy that allows us to source knowledge from people and put it into a database and reward those people with tokens. And then, of course, if you're collecting information and knowledge together, then it'll be fragile. So we know that AI is very fragile at the moment. So the second thing we do is use real-time communications to allow people to actually watch the question and answers in real time and intervene and fix them. And then the third thing we do is, when an AI is talking to you about booking a flight or booking something, it needs to know an awful lot of information about you. And the danger, of course, as we know with the Equifax breach and various breaches, is the wrong solution is to suck all that data into a central database and then hold that data about you. What you really want to do is to ask you for your data each time. So we need a sort of an API or a system that allows us to, as you're asking an AI question, the AI can go to your database and say, I need to know where James Bodie lives. I need to know James Bodie preference for an airplane seat. I need to know all these pieces of information. I need to go and get them in real time so I can give you a sensible answer without me being, large corporation A that sucked all this information in. The problem is if that's happened, you can't go and buy a service from large corporation B. You're kind of stuck. So this is what we're fixing and doing. And so what happens in our system is that you ask a question and an AI algorithm, similar sort of to the one that you'd have in the Google Go game, looks and says, is this a question that AI can answer easily, or is this a question that I need a human being for? And it flips between the two, and it uses Monte Carlo in order that even if it thinks that the answer should be an AI answer, sometimes it will ask a human being. So we kind of keep humans in the loop. And then those humans answer the questions, and as they answer the questions, they add to the AI interface, knowledge base. And then to make it all very complicated and tokenized and so on, tokens flow around that network when those things are done to monetize it. I won't go through all the token economics, but it's a fun sort of discussion for later. And that creates effectively a knowledge marketplace. So you have people with expert knowledge about dizziness or the law or whatever, putting knowledge into an AI, maintaining ownership of that knowledge, watching over that knowledge. Very often they need to watch over it. If they're a doctor or a lawyer, they need to make sure that the advice that's being given is actually good advice because it kind of comes with their name on it. And then customers can buy that. How do we get it out there? We've integrated with a bunch of messaging and web-based systems. And let's have a play. So I'm going to be my own minder. Now, this is live, so James will immediately type this in and join in. So it's chat.send.ai. Let me just check, do a sound check. So sound check is working.
Hi there. Please let me research for you.
So you can see that I'm in intercept mode in here, and I can now actually watch the conversation in real time. And then if someone asks me a question, then I'll be able to just kind of leap in and answer it. For the web, it's single-threaded, so each and every person gets an independent conversation with me. So I have to be able to manage all those conversations and see which ones are live. We also have it in Telegram. Now in Telegram, this is also live, and you can join in if you wish. So in Telegram, this is effectively multiple-threaded, so that a single chat can be monitored as a single linear chat, and every answer goes to every person. So it's a public chat, but we still know that a particular person in that chat is a particular person, so we can answer and say, yes, James, that's the right answer. No, it's not. We've integrated a few other kind of things. So this is WebGL. We also did a WebRTC version. So there's some debate about whether it's better to render the avatar, the robot or whatever in a central server and pipe it down using WebRTC, or render it using WebGL in the browser. You can also, and we've done it again both ways, if you answer a question, or if you're in a discussion about something with someone, then both in WebGL and WebRTC, we can look at the expression of the person who's getting the advice. So we can see whether they're kind of engaged and happy and seem to be getting good advice, or they're depressed and sad. So that if they're depressed and sad, we can mark that in the database and then go back and fix the answers. Also, you can, in this system, give it training hints. So if you get an answer, remind me later, if you get an answer you think is rubbish, you can type minus, rubbish, and that goes. Thank you very much. And that goes in the database as well. So you can actually build up a whole training session where you can implicitly train by being happy and sad. You can explicitly train by saying you're horrified. And then what happens after you've gone through the training, you have to go, at the moment, you have to write AML code. So you can go back into an AIML2 interface and write code that fixes these. So, for example, you can ask questions about SEN, about whether we're doing an ICO or not, which we can now answer. We are live on Start Engine. You can purchase shares and tokens in our company through the Start Engine website. Due to legal restrictions, I'm not allowed to tell you for how much money, how many shares there are, or anything like that. You have to get that all off the crowdfunding portal. But that's all kind of live, and so we built a little sort of regulation-approved set of questions and answers about our company. So you can basically use the system to build quite complicated question and answer systems about, writing a will or booking travel or whatever you want to do. But you can then have real-time people sitting in that channel watching that person, making sure that that's going right and stepping in if it goes wrong. And you can also then pull data from that person to fill in answers to the questions, so that you're not asking them every last question. So you're not saying, where do you live? Where are you going? Did you just book a flight here? So do you need a hotel for the same place? You've got all that information available that you can go and ask without having sucked it into one central repository that then can be attacked. So that's kind of our system and what we're doing. So this is the first time I have publicly demonstrated it working. I think it did work, didn't it? And I've done this with Ed Guy, who a lot of people here will know. So that's the same sort of team that did TruePhone and a bunch of other things that in the past, all traditionally VoIP, with a group of advisors, including Andy, who's currently in the back of the auditorium. Thank you, Andy. And that's the end, and I'll take some questions. I'm sorry I didn't talk too much about tokens, but I think it's more interesting to talk about AI and what you do with them rather than just arbitrarily talking about tokens. So I'm not criticizing your presentation. I thought it was brilliant. You can do things with tokens.
It's a great talk. Round of applause for James. All right, questions. I saw one over there.
Go ahead. Armor again. Here we go. You've got about 30 seconds.
So I still didn't understand, where does blockchain come into play? Like, you're just using blockchain to gather all that information? Like to ask for permission to gather user data?
So when you answer a question and you put it into the database, we tag that answer as an answer that you own in a blockchain, right? If that answer is then subsequently used to answer a question, then we give you tokens for having done that. So you're basically tagging your knowledge. So unlike a system where you might be hired by big corporation A, have all the knowledge sucked out of your brain, and then let go, and the system then goes off and answers questions. In this instance, you use the blockchain to tag ownership of your knowledge, so that as it's used in the future, you get recompense for it. And equivalently, you need to stand behind your knowledge. So if a question is asked and basically the answer is bad, is voted down, or the person frowns, or it's just evidently bad, then you need to be available online to be able to step in either in real time or shortly thereafter and fix it and make sure the knowledge gets better. So we're trying to build a knowledge base in real time that gets better and better. So jokingly, we'll do some PR on this, jokingly we sort of say this is a system that could pass the Turing test, at least in the limit, because every time it would fail the Turing test, would be about to fail the Turing test, a person can step in and override what the computer would do and fix it, and then make sure that that would be the answer given in the future. So you can kind of keep ahead of the Turing test, but obviously only by using human intelligence to do so.
Hi, James. So how is that knowledge then protected? Does it rely on intellectual property rights, or does it rely on people consuming the knowledge through the CEN platform? If the knowledge is now out there, how do we ensure that other people can't just go and use that knowledge and not incentivize?
Yeah, so the knowledge is not on the blockchain. The records of who owned which piece of knowledge are in the blockchain. The actual knowledge is in IPFS files. So there are some restrictions on doing whole-scale cloning. I mean, it's like directory attacks. If you own the Yellow Pages, I can clone all your data by doing a massive directory attack and just ask for everyone's name alphabetically in the world, and eventually I'll build a copy of it. So you protect it against that sort of directory attack, and you protect it with reasonable use.
And you're protected by the CEN platform. So, I mean, if it's sitting in IPFS and it's sort of encrypted,
yes.
Who has the decryption keys? Does the minder have the decryption keys, or does CEN have the decryption keys?
For information that's owned by an individual, only the individual can decrypt it. We can't decrypt it. So it's distributed in that way.
A quick follow-up to that. Where do those crypto keys live? Because humans are very bad at losing crypto keys. I know. Yes.
Well, I think this is one of the biggest problems that we have, right? That crypto keys are a nightmare. That's actually, I mean, that's one of the things I'm working on the most at the moment, is trying to work out how you cryptographically protect this in a way that real humans can use it.
Well, one way is you put it in a SIM, because we all carry around SIM-y type devices on us.
Yes, I mean, that's approximately the model that Civic took, and a lot of people are taking, which is to put the knowledge in your mobile phone, then back up your mobile phone to some arbitrary unknown storage location or difficult to find storage location, and then use your phone as your secure device. So you use your thumbprint to get into your phone. Once you've got into your phone, if the AI asks you a question, it asks a question with a /Q in front of it. That won't appear in your browser unless you have it in debug. It won't appear to you. It'll go off to the query system, which will get that information and send it back silently. So it's getting lots of information about you silently. It's getting it from your phone. So if you turn your phone off or kill it or whatever, there's no longer a way of getting to your personal information. Now, then you have, of course, what happens if I lose my phone? How do I recover my phone?
Well, that's easy. Just blow the SIM fuse.
Yeah, the problem is not usually destroying the information or rendering the information unavailable. The problem is usually someone's accidentally rendered the information unavailable by, say, dropping their phone in the river tonight. Don't do that, warning. And then how do you get back your information if you've destroyed it? So the obvious way to get back your information is there to be a backdoor. As soon as you have a backdoor, you have Equifax attacks. Attack the person who holds the back doors, and then use the backdoor encryption to get through everything. So this is a real trick. I mean, I know that PGP and so on have a web of trust. So the way that you would do it is you'd find 10 friends of James Bodie, and then you would use a shared secret method. And if you can prove 10 friends of James Bodie are James Bodie, vouch for him, then you can reconstruct his key from a shared secret and then reconstruct his data. But of course that assumes that James Bodie hasn't been rude on email that week, and people are talking to him.
Friends.
Yes.
Yes, a short one.
Yeah.
Oh, they self-select, and then they vote. And then they're voted up and voted down by the community, just like in Wikipedia or Quora. Pardon? Oh, you have to, if you say you're a lawyer or a physician or anything that requires legal things, then you have to go through the same process, due diligence, as if you walk into my clinic at Penrose Institute and say, I can operate on patients' brains and do MRIs on them. I have to make sure that you are a physician and take references and all that sort of stuff. So. Yes. If you're doing something that's regulated, then we have to go through the regulated screening. And there is just recently an FDA system for doing that. So, for example, there are now diagnostic and therapeutic computer programs and psychiatry programs and so on that will talk to you and diagnose you. There's a whole regulation around how the knowledge gets into those, what physicians have agreed on it, how you approve a device, how do you approve a computer program to give clinical advice. So we have to go through how you approve a program to give clinical advice. So that's nicely regulated. The law, of course, is not regulated. The law is, if you watch TV programs about lawyers at the moment, this is one of the biggest things, which is when is a computer program giving you an index of things to go and read, and when is a computer program giving you legal advice? And if a program is giving you legal advice, who is breaking the law? I'm quite happy for you to arrest Sen and take her to jail because I can clone her unlimited number of times. But obviously, if you then say that I have given legal advice because I'm the owner or runner of Sen, then and then I would say no, it's a distributed tokenized system. There is no central authority. You cannot arrest anyone, just as you can't arrest any Bitcoin person because there is no founder or central person of Bitcoin, as far as we know. So it's an interesting area.
So even if you're giving permission at one time to book an airline ticket, what's the guarantee the system cannot clone that information and store it locally somewhere?
Oh, I mean, everyone can cheat, right? And at some point you have to have trust. The way that Europe has dealt with trust is if you break that trust, you'll find 10% of your worldwide turnover for each time you've done it. I think you get let off with an only $20 million fine for the first one, and then it's 10% of turnover. In America, you get a class action lawsuit against you, and lots of people would sue you for all sorts of things. So, you either do it right because you're trying to do the right thing, or you do it right because you're scared you'll go off to jail. I mean, that's the same for anything. every telco could listen to your credit card details that you read over the phone when you book anything and steal your money. They don't.
Wonderful. Thank you, James. Big round of applause for James Tagg.